Okay, so let's continue on. This is my second video for you. This is problem number 4, right? And I just want to make sure you understand that we are told that AB and AC are each tangents to the circle. Well, one of the rules or properties or theorems that you should truly understand is from any exterior point, I can first of all only draw two tangents. And you should know that they actually make a right angle when I connect the point of tangency with a circle. Now, we don't need to know that for this one, but you ought to know that they do make right angles. The most important thing is, if you think about it, hopefully it's logical, we know that this tangent's got to equal that tangent. So therefore, we're going to take 11y, set it equal to 3y plus 4. And all we have to do is solve for y, plug it back in to find the value for each of the tangents. So I'm just going to go ahead and minus 3y here. That means that 8y is 4 dividing by 8. I know y is 4/8, which is 1/2, or 0.5. Now, I don't know if your teacher allows you to use a calculator or not. I would. But 4/8 is 1/2, right? Or 0.5. So now what? Well, we can plug it in here and in here, and we ought to make sure it works out. So notice if I do 11 times a half, that's 11 halves, or 5.5, 5.5, right? If I plug in 1/2 into the other equation, or 0.5, whichever. Notice I get 1.5 plus 4, which is also 5.5. So, long story short, I just want to make sure my math worked out perfectly. I know that this right here is 5.5 or 5 1/2 in length. So tangents from the same point always are equal to each other, and they always come in pairs like that. Okay, let's look at 5. Now, this is a cool one. The best way to remember this one is notice what's special here is we have chords. We have this chord drawn inside the circle and this segment drawn inside the circle. And whenever you draw segments in the side of the circle, they're called chords. Oops, sorry, my hand keeps getting in the way. They're called chords. And what we know is chords, when they intersect, always cut each other proportionally. So the best way to handle this one is just to set it up as a proportion. For example, I notice that 3, which has x as this other piece, right? So x will go with 3, just like we're going to say 2 goes with 9. Actually, I'm messing up a little bit. It's actually simpler than this. All you have to do is cross multiply. Sorry, I was just doing a little brain fart there. So I know that 3 times x is 2 times 9. So whenever chords intersect inside the circle, basically just think, I'm just going to cross multiply. So this piece times this piece equals this piece times that piece. And so notice 3x equals 18. Dividing by 3, x is 6. Let's double check my math. If I do 3 times 6, that's 18. And of course, the 2 times 9 is also 18. And so, yeah, so what's the value of x? It's got to be 6. The length from here to there has got to be length 6, because this 3, its other piece of it, let's say, times it should be the same as taking, again, the 2 times the 9. So as a follow-up, let's say I had a circle, and again, they crisscross like so. I don't know what this is, but let's say this is 6, and this is 3, and this is 8. I'm simply just going to cross multiply. 6x equals 3 times 8. So 6x would be 24. I made up this problem, obviously. So x this time must be 4. So inside the circle, remember just to cross multiply them. So I hope this helps you going over problem 4 and 5. And I'll make probably at least one more video and see how you like my videos and how they help you or not. And then based on that, we can make more videos. Again, just send me new material if you like, through your mom, of course. And I will make videos on those as well.